All right, so we have a voltage regulator and there's a way to determine if that's operating correctly. What should happen is as the demand changes, it should adjust accordingly. So a test we can do is turn things on, turn on the headlights, turn on the defroster, the windshield wipers, things like that. The load should be regulated to 13.5 to 14.5 at about 10 amps or less. It should also be the same at between 10 and 20 amps. So what happens is it should be proportionate. As we put those loads on, we should see it correct itself. And we should see it correct itself again. Okay, so it should always maintain at a certain level. The amperage comes up, the voltage tries to recover itself to some degree. If we go a lot, then the voltage starts dropping quite a bit. But the fact it corrects itself means the regulator's working. All right, so there's another test we can do to determine how much electrical power our vehicles need. We connect an inductive ammeter to the negative battery cable. We turn on the ignition, but we don't start the engine. We turn on every accessory we can find at their highest level, and the amperage that shows on the meter is how much of an alternator we need. Actually, we probably need a little bit above that amount, but it's a good indication of what we need. So let's talk about replacing things. All right, we have to replace an alternator. You're going to have to do it on your lab whenever you get a chance to do it. We disconnect the negative first before removing the alternator or any wires from it. We use a belt tension gauge to determine how much belt tension there should be. And you saw one of those in 101. Not 100% necessary, but it's a good thing to figure out what you had when you started with. Never pry on the rear housing of the alternator. It's a cage and it's got heat openings in it and it's fragile. So if you pry on it, you'll crack it. And then tighten all fasteners to the proper specifications. And here's some pictures of removing alternators. Right, so you can see this one, there's two 15mm bolts. We loosen them up, we can slide it out of position. Now, one thing you got to recognize is there are sleeves in those aluminum brackets that take up the slop from machine changes and whatnot. So you might need a hammer to tap them in or tap them out, all depending on how tight they actually are. Okay, you can see here we have a adjusting bolt, and we have a little cam in here. We tighten the bolt, and this thing allows the alternator to move up or down for the belt tension here. You've got a bolt here. You've got this one that goes through a bracket. This bolt goes up and down. It's threaded into the head of this bolt and allows the alternator to loosen the belt tension. You can see it on this one too. Here's a bolt here. You loosen that one up, and this alternator will slide back and forth. And you can see the adjustment point right here. This one's fixed. This one over here, you loosen it, and the alternator will drop out of position. Okay, this is a belt tensioner. And you'll have to take it, and you'll see one way is going to tighten, the other's going to loosen. It's got a spring here, and it's going to allow this to bend out of the way for you. It's going to spring back afterwards, so you just have to be able to put your tools where you're going to have enough room to get your tool back out afterwards. Now, there are stretch belts on a lot of cars, and you'll look at it and you'll go, how do I get that off? Well, they're meant to be used one time, and you actually cut them off, and they actually have a tool that goes onto them to try to derail the belt on. There are a handful of cars that have it, and you might find that along your way. And then here is a little shock absorber that are used on a lot of German cars. And you'll see there's a bracket here, so you got to compress that. I believe there's a picture here of what somebody did to help compress it. They put a hose clamp around it, they squeeze it down, and it holds it in place. And I think that was a brilliant idea.